Hi, 大家好. My name is James C. Lin, and today I'm going to share with everyone what Missile8964 actually does in theory and in practice. And we are going to use an example of building a supercomputer with it to explain everything. Scalability. It is not a new concept. In a nutshell, it is a system's ability to increase its capacity and ability for the task at hand that it already does. The example here is a search engine which supports increasing numbers of users and the number of topics it indexes. So to achieve this task, the system must be able to handle the increased network traffic and also the processing capability in the background. Next, modularity. There are plenty of examples you can find on this wiki page about how modularity is done in all kinds of industries. However, here we will confine the definition to the following. The concept of modularity is used primarily to reduce complexity by breaking a system into varying degrees of interdependence, independence across, and hide the complexity of each part behind an abstraction and interface. In a nutshell, this is the ability of a system to quickly interchange its functional parts, either because the desired functionality changed or some of its parts broke down, and being designed with modularity makes it easier to replace the broken parts. Now, with the definitions of scalability and modularity taken care of, we are going to begin the first combined concept of both. We defined it in a simple sentence: easily add heterogeneous components as necessary. That would expand Missile8964 from a single board computer to the following: a combined laptop, tablet, or smartphone in computing, in vehicle, vessels, and aerospace applications. It will accomplish the following feats: 1. Fly-by-wire. 2. Steer by wire. 3. Brake by wire. And 4, which is the most innovative. 1 is for maintenance, fluids by wire. In medical and pharmaceutical fields, we are able to apply this principle to medical devices and drug administration in the hospital. And finally, in architecture and civil engineering, we are able to apply this to healthcare delivery, logistics, and guaranteed habitat, which is our saga egg. This is an original theory and technology by James C. Lin of De La Contour. Now we flip the two words around and we get scalable modularity. By our definition, in a simple sentence, that is to easily increase specific functionalities or capabilities and, most importantly, capacity as necessary, as required by the task at hand. And here is the same list of industries and technologies that we are applying this to. So we are doing both modular scalability and scalable modularity concurrently. And this is why we are able to apply Missile8964 to all of the aforementioned fields and industries. We are going to demonstrate by building this Missile8964 configuration on demand supercomputer. The concept of a single board computer is pioneered by the Raspberry Pi company based in United Kingdom. We are going to trust them to help us design and build these single board computers and profit justly, and also find a way to make sure our co-prosperity circles will have their factories to manufacture them locally, because it is important that every prosperity circle own one of these. The next important point is the ARM instruction set based CPUs, or RISC reduced instruction set. ARM is based in the United Kingdom. However, it is also owned by its parent company, SoftBank Japan. All ARM-based chips needs licensing from ARM. For example, Apple Silicon. Another type of chips that we are welcoming in is the RISC-V instruction set based CPUs. It is an open source project originated from the United States. It is also reduced instruction sets, but because it is open source, it is harder for companies to profit from it. However, we are hoping that we can help it get on its way so that more chips can come from it. However, it is not as mature as ARM, and the chips coming out so far are not as powerful. But the software is there already. Linux already supports RISC-V instruction set based CPU to run a normal Linux desktop operating system. There is another school of CPUs from Intel and AMD that is based on CISC, complex instruction sets. This is the older school which used to work brilliantly. However, in comparison to RISC-based CPUs, they are much less energy sufficient and also generate much more heat. In this example, we are going to build a supercomputer using 126 CPUs or single board computers. The example we are using here uses 16 gigabytes of RAM on each board. That will give us 2016 gigabytes, which is almost 2 terabytes of RAM. The overall packaging, the physical size of the unit is only 300 millimeter by 210 millimeter, and by height 224 millimeter, which is 30 centimeter by 21 centimeter and by 22.4 centimeter. So the height of the unit is only 8.8 inches if you use that system of measurement. It is important to note that when we are building these systems, we build them on demand, so we do not have to build them to this maximum capacity of 126. The physical limit of USB-C standard limits us to 128. Then again, because of scalable modularity and modular scalability, we are as free as we can be for our task at hand. In this first example, we are going to include a Kokoro single board computer. That is the one that comes with telecommunication, Bluetooth, and NFC communication chip. Now, a quick recap on the ARM-based CPUs. The first one is the ARM chips from United Kingdom. They have already started the process of trying to build their own foundry in the United Kingdom, which is a good thing. Also, one of our boys, Qualcomm, the company that built all the Snapdragon chips in the Chromebooks and in a lot of the Android phones, we believe they have something that is the direct competitor to Apple Silicon ready in their lab. Also, we have Samsung, who has been producing their own chip, Exynos, for a long time. All of the aforementioned chips are ARM-based. Originally, we didn't plan for Intel. One is that they are so big, and two is that they are so committed to the CISC architecture that we were not sure if anyone could sway them. However, as event unfolded, we are going to provide a pathway for Intel to transition into the realm of RISC instruction set if they wanted. They used to produce a M-series chip. They were pretty good and also did not require thermal fans when in use. The other board that's been defined from the very beginning of Missile8964 is the Robin board. And in our plan, we want this one to have exactly the same PCB board layout as the Kokoro board. So the production will be cheaper. But by adding and omitting components, we can switch between the two. And in this example, we redefine the Robin board to have 16 gigabytes of RAM, but minus all of the telecom functionalities, but with one optional micro SD slot, or it can use an external storage option as we defined in another video. We use the same 3x3 grid, but we use two plates at once to house 9 CPUs in an alternating manner. The one on top houses 4 SBCs. The one at the bottom houses 5. The extra slots can be used to house either a battery or a thermal fan, as shown here. Each plate is 8 millimeter thick, so 2 plates gives us 16 millimeter thickness, which is 1.6 centimeters. Every 2 plates gives us a set of 9 CPUs, and if you multiply by 14 sets, that would give us 126 CPUs in total. If you add a single power source via one single full data, the 24-pin USB-C standard connector, it will run at 100 watts power delivery, and you get to pick and choose 5, 9, 15 or 20 volts and 5 amp maximum. This capability to run multiple CPUs on demand is the reason why chasing the nanometer race in CPUs, in semiconductors, is completely insane and unnecessary and meaningless. In our plan, it is even possible to mix and match CPUs from different architectures. If you have mission critical tasks, you might want to stick to one single architecture. But we do have the confidence in the current state of software to trust it, to use it in medical or architectural applications. This alternating grid allows us to sandwich thermal fans in empty spaces or even just leave them open, because most ARM-based or RISC-V based CPUs do not require cooling fans, or as we call it, thermal fans. However, this arrangement allows us to provide the best thermal solution of any computing device. So here on the right, we have an alternative configuration that is strictly Robin boards. This is actually quite useful for occasions when you just don't want telecom capability at all. So this is just a repeat message. Same thing, same compact size. And the same power situation applies. We are using the USB-C 3.0 PD standard. However, there is the 3.1 standard, which allows it to deliver 240 watts. So this is just one option to keep in mind. The power option also include to have a plate of 9 batteries. If you connect them using the 6-pin USB-C connector for power only, it does not count as extra USB devices. This will count only as one, but it delivers 5 volt at 1 amp only. If you want the full 100 watts, just connect each one using the full 24-pin connector. But remember, they count as 9 USB-C devices within the 128 limit. Another option is to include solar panels. Now you can build one with the dimensionality of 300 millimeter times 210 millimeter with 8 millimeter height. However, you can also use 9 smaller panels as well, and the same power situation applies. Again, if you use 9 separate ones but connect them with only the 6-pin connector, it only delivers 5 volt at 1 amp, but they don't count as extras. Now, in certain situations, you might want to add extra thermal solutions. Here is an example of a plate of 9 thermal fans running at 5 volts, 1 amp. We foresee this for military applications and other crazy stuff. In the beginning of June 2023, Jensen Huang of NVIDIA came to Taiwan and claimed to have this trillion-dollar company and has the following companies all coming out in support of him, claiming that they are Taiwanese when in fact he is on his way to China around June 4th or June 6th. In between this time, we came out and challenged him to reveal the lies about his technology. Imagine this gentleman having all this list of technologies in Taiwan, pledge allegiance to the CCP and Xi Jinping. The list include TSMC, UMC. Its supposedly retired founder was the orchestrator behind this. MediaTek is a subsidiary of UMC. Another one that comes out in public support is the CEO of ASUS. We include Acer and BenQ here because these 3 companies actually belong to the same family. Then we have HTC, who also came out again, who has claimed in the past that they were Chinese and not Taiwanese. And finally, we have Foxconn, the sweatshop of the world. This is why it is important that all the sanctions that we are applying in terms of semiconductor future that we are applying to China also must apply to Singapore as well, because UMC has a large number of foundries in Singapore. Also, the way Mandarin Han money from China is infiltrating Singapore. We just don't trust anything that's in Singapore anymore. Now, since June 4th, TSMC suddenly makes the announcement that their breakthrough CoWoS 3D packaging process is here and how important it is. It is not. What we mean by this is it is a nice breakthrough in technology. But again, this is inconsequential to real AI or even AI at all. They are just using it to do their last-ditch effort, propaganda, when we previously revealed that they were just the labor-intensive part of semiconductor industry. We do not advise any nation to invite TSMC to set up foundry at all. It is safer to sanction TSMC out of existence because of their association with the Mandarin Han clique. Remember, these are top managements who have CCP ties and also political ambitions to be associated with China and the CCP. It is just not worth it to risk our national security in their hands, because you should know by now that they collude together. They pledge their allegiance to China and CCP. Oh, last but not least, just a reminder that our Cockerel SBC is also the basis for our smartphone configuration. Okay? So this is the copyright message, who I am and what I do. Again, Missile8964 is protected by the Solilock license. We include the latest version of the license in the next few slides. However, you can find the latest version at this URL. Thank you.